What we're going to be looking at is being able to solve with fractions. There are actually two techniques, and it depends on how many fractions there are in the equation. There's actually a few techniques. We saw before that if there was only one fraction in the equation, as we talked about this today, that we could undo all the operations around. I don't see one here. No, that has more fractions. But in a problem like this, we could undo all the operations by subtracting the 4 and then undo the division of the -3. Just follow the reverse of the order of operations. Follow our steps for solving. However, if there are more fractions, you have to make a decision. You can either convert every fraction in the problem to having the same denominator, using the least common denominator, or as long as it's an equation, anything we do to both sides will keep the equation balanced as long as we do the same thing to both sides. So in this case, one of the preferred methods when there are a lot of fractions, as long as it's solving an equation, if it's not an equation, you can't do this, is to multiply every term on both sides by the least common denominator. With our first two problems, we're simply going, because there's only one term that has x here and nothing around it, we're simply going to undo this by multiplying by the reciprocal, multiplying by 4/3. 4 times 3 is 12, 3 times 4 is 12, 12 over 12 is 1, so this just becomes x. Or another way, the numerator and the 4 in the denominator, they cancel out, leaving a factor of 1. The 3's cancel out, leaving a factor of 1. 1 times 1, 1 times 1, we have 1x. Whatever I do to the left, I have to do to the right. So 12 times 4/3, or 12 times 4 divided by 3, or 12 divided by 3 times 4 gives me 16. We can plug that back in to double check it. With a problem like this, we're going to look for the least common denominator. We have 7, 2, and 14. You can list the multiples if you want, like you did in middle school, but most of you will not need to do that, where you list them all out and look for the least common multiple. So far, 14 is it. So since the least common multiple is 14, rather than have to work with fractions and have them converted, which you should be able to do because in Algebra 2 you'll be given expressions like that where there's no equal sign and you will have to convert fractions. But for now, we're solving. So whatever I do to one side, I can do to the other side. So I'm going to multiply every single term by 14. Here, 14 times the expression x minus 3 over 14, the 14's divide away, leaving me a factor of 1. So I have x minus 3 on the left-hand side. Here I have 14x over 7 plus 14 over 2. This gives me 2x when I reduce 14/7 is 2. 14 over 2 is 7. Now we have a linear equation like the ones that you solved in middle school and solved in your summer packet, where all I have to do is follow the steps. So there's nothing left, there's nothing to distribute. I'm going to get my variable to one side by subtracting x from this side. So I have -3 equals x plus 7. I don't have any addition or multiplication or division to undo, but I do have addition to undo. So I'm going to subtract 7 from both sides. X equals -10. And I can plug that back in. -10 minus 3 is -13/14. -10/7 plus 1/2, which would be 14/7. And something's wrong. Let me see what I did wrong. Give me 1 second. Sorry about that. I see what I did wrong. I wrote this as 14/7, and that didn't make sense. It was actually 1/2, which would be, we'll have to convert it all back. So this was plus 1/2. So to make this 14ths. I'd have to multiply this by 2 and this by 7. So this would be negative 20 14ths plus 7 14ths. Negative 20 and 7 is negative 13 14ths. So we did it correctly. And when you plug it back in, it does work. Let's take a look at letter D and E. Letter D, to solve, the first thing I'm going to do, because there's only one fraction and that's on the variable itself, I'm going to subtract 1. So I have 5/4 x equals, so in effect I'm really subtracting 8/8. 13 minus 8 is 5, so I have 5/8. Now to undo this multiplication of 5/4 on the x, I'm going to multiply by the reciprocal 4/5 to both sides of the equation, giving me 20 20ths, or 1x on the left-hand side, 20 over 40 on the right hand, which if I had just reduced the 5s would be 4/8, or 1/2. So x equals 1/2. We can plug that back in to check our answers. Letter E, there are multiple fractions and multiple variables involving fractions, and so I can't just undo the order of operations. I need to find the least common denominator between 28, 7, 14, and 4, and 28 is the least common denominator. So we're going to multiply these by 28 every single term. So in effect, both sides of the equation are being multiplied by 28. 28 times 3 over 28 is just 3x. 28 times 1 over 7 is 4. 28 times x divided by 14 is 2x. 28 divided by 4 is 7. Makes the equation much easier to solve. So now I'm going to get my terms to one side. I have x plus 4 equals 7. Subtract 4 from both sides, x equals 3. We can plug that back in. That would be 9 28ths plus 1/7, which in terms of 28ths, I'd have to multiply that by 4. It'd be plus 4 28ths. That's 11 28ths. On the right-hand side, I have 3 14ths plus 1/4. We've got to convert those to 28, so we're going to multiply this by 2. That's 6 28ths plus, here we have to multiply this one by 7, so 7 28ths, that's 13 28ths. So, oh, 9 plus 4 is not 11. 9 plus 4 is, I did 9 plus 1, is 13. 13 28ths and 13 28ths, the equation's balanced when we plug it back in.